and welcome to At Home with APS. My name is Mrs. Sears, and shortly we'll be joined by Mrs. Gaudette. And today we're going to be working with you on 3rd, 4th, and 5th grade math. We're very excited to get started today. We're going to do some routines for you, then move into a problem-solving task. Finally, we're going to have a read aloud and then play a game at the very end. So we're very excited to get started with you today. Our first routine is going to involve something called Splat. If you haven't heard about Splat, it's a really cool resource that we've attached to our information on our website for you, and it's by a gentleman named Steve Wyborny. And let's just get into what Splat is. All right, so I have a blank screen behind me, and you're going to start to see some representations. What number does this represent? Well, if I'm kind of looking at the picture really quickly, I can see that there are 3 circles that have a blue filled in or shaded space. That means that there's 3 holes. And then I see 4 circles that have a red smaller portion shaded in. And that's a 1/4. And so if we know anything about our numbers as we're adding them up, 1/4 plus 1/4 plus 1/4 plus 1/4, that gives us another whole number. So the number that you're seeing that's being represented is 4. All right. What happens if I covered it up? Splat. We need to figure out how much of whatever is underneath is covered up. That's how the splat works, okay? So what is the total under the splat? And how do you know? So this is kind of sort of like what we've done before when we flashed a number at you and you're trying to figure out what portion of that number you still need to figure out. How could we figure this out without removing the splat? I have a couple of different ways that I could think about doing it. I can see, remember before we had 3 whole pieces? How many of the whole pieces do you see now? You see 2. Okay, so we know, well, at least what we can see, let's go ahead and write that over here on the board. What we can see is 2 whole pieces, and how many of that smaller portion do we see? 1/4. Okay, what are we trying to get to? We're trying to get to that 4, the 4 whole pieces. All right, you might remember before we said that we had 3 whole pieces, so we know we probably need at least 1 more of those whole pieces. The question would be, do you remember what was underneath the splat? Maybe let's think. I know we have 1/4. How many more, if we have 2 of one whole and 1 other whole, that's 3. How many more of the 1/4 pieces do we need to make 1 whole? Well, let's see. I know there's 4 out of 4 pieces that I need, and as long as I have that like denominator, I can just add whatever amount I need to the numerator to make that 4/4. So probably more than likely what we're missing is that 3/4. Let's kind of move on and let's see what it tells us to do next. All right, how else could you know? Now this way we did addition, right? But we've been practicing in our fraction of the day routine that we could also do subtraction. So let's write that as a subtraction sentence. How could we do that? I want to make sure we equal 4 wholes, right? All right, so what did we start with? We know that number's supposed to be that 4 wholes. How many did we have there? We had 2 and 1/4, okay? So this is more thinking, again, how are we gonna figure out what is it that we need left to use? Well, we can't just take our whole numbers and subtract them out because we do have a portion of another number that's sitting right next to it. That 1/4 does make a difference. What do you think we could do? We could kind of do it like on that open number line that we've seen before. Remember on that open number line? So if you were starting at that 2 1/4, and you've got to get to that 4 over here. How much could you add to it to get to maybe that next whole number? You could add that 3/4, right? I'm going to hit a plus 3/4. That would get us to 3/4 plus 2 1/4 is going to be 3. How many more do we need to get from 3 to 4? That whole number, right? And then we can use what we did, sort of that addition to help us solve that subtraction. We would know that that 4 minus 2 1/4, hopefully you guys can see this, is going to be that 1 that we jumped and that 3/4 that we jumped. Oops, let me make that better. I meant to kind of leave that fraction part there, but it looks like I just crossed it in there. So that's another way that we could know, right? So 2 different ways that we can look at it, 2 different ways that we could think about how to figure out what is behind the splat. All right, so let's look to see if we were right. And what can we learn from that picture, right? All right, let's do another one. What do you see here? I'm going to flash it for you quickly. How many is it? 7, right? All right, I see 4 holes, and then I see a combination of those quarters, okay? So, excuse me, I think, yes, we do need to combine some of those quarters. We've got 1, 2, 3, 4, 5, 6, 7, 8. This actually should say 6, I think. Am I reading it wrong? Because I see, oh, there's 5. I'm seeing it a little bit differently. It's 5 plus we have 4 quarters. There's actually 8 quarters, 8 fourths, which would be 2 extra. All right, covering it up. Can you remember what was underneath that splat? Let's think about our 2 different ways that we can do that. We go over here. So we have how many to begin with? 7, right? Did you remember what was underneath? Let's see. So what did we do first? We wrote what we could see. We looked at our picture and what could we tell already from the picture? We have 1, 2 holes. We write that for you. And then how many? 1/4, or I call them a quarter. I always think it's, for me, easier sometimes to be thinking about how much in terms of like money. A quarter to me, I can remember 4 quarters as $1. So when I think of a 1/4, I think of like quarters or money in my head. And remember, I want you guys to be doing this at home with me too. Not just me doing the thinking. If you can be thinking about it and like shouting out those answers, what do I think's behind that splat? That's what we want you to be doing. All right, so we have 2. How many fourths? I see 1, 1/4. 2, 2/4 there, 3/4, 4/4. I know that's going to be a 1. And then I have another quarter, right? So in total, I have, on this line, I have 3 1/4. And make sure that I'm also saying that and. That and is very important. Okay, because we don't have that piece of that number that we're working on. It's not a whole number, so I have to say that and, okay? So we started with 7. Now what? Actually, I think last time we started with our 3, and hopefully you guys can see that, and our 1/4, and we were trying to figure out how many were under that splat. We were going to use addition to solve it. How many more would I need to get 1 whole? Oh, remember we were talking about this before. The 1/4, we need, as long as we have that 4 in the denominator, we just need to have another 4 in the denominator and then add those numerators so that we have 4/4, right? All right, so I know I'm going to need at least 3/4, okay? That 3/4, and I'm going to just do that kind of like on our number line as well, because that will help us figure it out, and we can rewrite it in a different way. We need that 3/4. That's going to get us to 4. All right. Then how much more do we need? 3 more, right? All right. So let's rewrite this, okay? 3 1/4 plus how many holes? There's 3 holes. And how many of the pieces of the quarters do we need, or the fourths? 3/4. That's going to give us to that 7, right? If you were rewriting it in a subtraction sentence, we would be doing that 7 minus what we can see, the 3/4, is going to give us 3 3/4. Let's see if we were right. I don't know if it pops back up. I think it doesn't always pop back up to see if it would. Nope, it doesn't. Oh, I have to go backwards? Oh, there we go. Thank you, Miss Cadet. So let's see where we write, okay? Remember that splat covered that little area right over here, all right? We did have our 3, and then we had like 5 of these quarters that were left. Let's see if we were right with what was left over. So what was left over, if I remember correctly, it was this one, and this one. There's our 3, and then where were our 3/4? They were right here, right? 1, 2, 3. That's pretty cool, I think. Yeah. Let's do one more, and I'm going to leave it with you to try this at home. Okay? So let's start with our number. How much is there? Okay, I can see 3. 1, 2, 3, 4 holes. Okay, we have 4. And this time it's thirds. Ooh, that's going to be interesting. How many thirds do we have? We have 1, 2, 3 thirds. 3 thirds, that's going to be 1 hole. This number must be 5. All right, you ready to splat? And I want you to do this one at home. We have a few more for you as well. What do you think is going to be underneath the splat? I think this is going to be a fun one for you to try. Miss Gaudette is going to come and join us, and she's going to do some problem solving with you for multiplication and division.
Can you forward me on?
Sure.
So really fast reminder to have a math journal, have a piece of paper, have something that you can do the math with me. Reminder, I always want you guys to attempt the math before you watch me answer it so that you have your thinking done first. Then you can shout, celebrate, shout hooray, or you can modify your work. All right, so let's go ahead and get started. Let's read through it. And again, we're going to do the adapted marking the text where we'll circle the numbers and underline what are we being asked to do. Draw an area model and then solve using the standard algorithm. Use arrows to match the partial products to the area model to the partial products of the algorithm. All right. So, that was a mouthful. All right, really fast. What's the first thing? Do we have to circle anything? There's no numbers yet, right? There's nothing, but there is a lot of information we're being asked to do here. What's the first thing we're being asked to do? Draw an area model. So I'm going to go ahead and I am going to underline that so I know I need to do an area model. And then I have to do what? I have to use the standard algorithm. And for some of you that are kind of going, I don't quite remember what those are, don't worry, we're going to go over them. And then I am to use arrows to match the different pieces. So I'm going to just underline use arrows because I know I'm going to match the area model to the standard algorithm. So my numbers I have to work with is 34 multiplied by 21. So for area model, what we're doing with that is we're just showing how our multiplication is. So I like to do a box, a square, a rectangle, normally a rectangle, because it just works the best. Then I take my first number, 34, and I break it up into our ones, tens, hundreds, thousands, however big your number is. We only have up to tens. So I'm going to take my tens, which is 30, and then I know that I have 4 ones left over. Because I split the number up, what do I need to do in my area model? Some of you got it. Some of you are like kind of, I don't quite remember that. It's okay. That's why we're going over it. We have to draw a separation because we're going to multiply first by 30, and then we're going to multiply by 4. My next number, I have 21. I need to split it apart by 1s and 10s. What are my 1s here? 1. What are my 10s? 20. Now, a lot of you are going to say, Mrs. Gaudette, wouldn't you put the 20 on the top and then the 1? You could, and it works fine either way. I did this because it just works very well with what we're going to do next. So that's why I put the 1 on the top. And then, of course, I got to split it up so I can make sure I do my multiplication. Now we do it. What is 30 multiplied by 1? 30. What is 1 multiplied by 4? 4. See how nice this is? You can kind of start seeing it. What is 20 multiplied by 30? 600. And then what is 20 multiplied by 4? 80. All right, really fast, what I'm going to do is I'm going to add a cross in my area model, just because that will help us with our standard algorithm. So 30 plus 4 is 34, and 600 plus 80 is 680. All right, there is our area model for our first equation. Now let's go to the standard algorithm. The standard algorithm is just a process that helps us get to the answer fast and easy. Almost like we just it becomes a step-by-step rule for us. So I'm going to give you one way that I do it. So what I do is I take my 1s, just like I did here, and I multiply my 1s by my 1s, and then my 1s by my 10s. So if I multiply 1 by 4, which is my 1 spot, that is 4. Then if I multiply my 1 by my 10s going diagonal, I know that I'm multiplying 1 by 30, just like we did here. 1 times 30 is 30. And some people may see looking at, Mrs. Gaudette, you told me the answer's 30. Wouldn't I put 30 in front of the 4? But if you look at our number, you will notice that I have 34. So my 30, which was my 3 10s, is in my 10 spot. It is already 30. We don't have to add anything else to it. Then my next step is to multiply by the 20, just like we did here. Because of that, we always, in this standard algorithm, we put a 0 to make sure to know that we're multiplying by 20, not by 2. When I was a kid and I learned this standard algorithm, I'll be honest, it was just a step-by-step rule that I just followed and didn't understand, and I messed up a lot because I didn't understand the reasoning behind it. That's why I'm talking with you step-by-step why it's happening and how it's happening, okay? So I know multiplying by 20. So I'm doing 20 times 4 is 80. You notice I'm going to put my 8 here. And I had said it was 80, and it's in the 10 spot, and I have my 0 to prove that it's 80. Then I move where I'm multiplying 20 by 30. What is 20 times 30? 600. So you notice I am in my place value of hundreds, and I put my 6 there. What I do to solve this, my last step is to add the 2 numbers up. So before I do that, let's look over here on our area model. We forgot to add it up. Whoops. So what is 600 added to 80, added to 30, added to 4? So I know it's going to be 600. 600, 80, 90, 100, 100. Oh, did I just do a boo-boo? Yeah, it's a little one. That's what erasers are for. Because I'm one of those ones who I go straight in and just add the bigger number and then and then realize, oops, I should have done something else. So I'm going to start with the 1s. So we have a 4. Then I add my 10s. So it's a 80, 110. You guys, you notice I almost said and there? Did you catch me on it? Remember, we're playing a game. How many times Miss Sears and Mrs. Gaudette will say the and when it's not supposed to be there? All right. So I have 110. So I have my 10, and then I take my 10 tens and move it over to my hundreds, which is 6, and I add one more. So I'm saying the answer to this is 714. Let's double check. Let's see what we got over here. 4 plus 0 is 4. 8 plus 3 is 11. And I carry, which is 11 tens, so I'm carrying my 10 tens over to that, which is 100. So 6, 7, so I have 714. Did that match? Yeah. Have I done everything it has asked me to do? Draw an area model? Done. Use the standard algorithm? Done. Use arrows. Oops, I forgot to do that. So what we're doing is we just show here that 34 on the area model on the top is the same thing in the standard algorithm where I multiplied 1 by 34. The 680 where I multiplied 20 by 30 and then 20 by 4 is the same thing as second step in the standard algorithm where I multiplied by 20 there. And I ended up getting the same answer. All right, so let's move on to the next one. It's a little bit bigger number. I have 434 multiplied by 21. So again, I have to draw my rectangle. I need to split up my 434. Yep, we have 400. It's like taking it to expanded form plus 30 plus 4. Then I have to draw my lines to show my addition, the different pieces I'm going to multiply, and then 21. Split it up like expanded form. I'm going to put my 1 on top because it helps when I do my arrows, and then my 20. All right, and then draw my separation. Now I go ahead and I do my multiplication. 1 multiplied by 400, 400. 1 multiplied by 30, 30. 1 multiplied by 4, 4. I added across 434. So I'm thinking in my very first row in my standard algorithm will be 434. We'll have to double check. Now let's do 20 times 400. That is 800. Did you catch me? Because guess what? If you had seen my math, this is what I did. I put 800 and then realized, why didn't my area model match my standard algorithm? What's going on here? It's not 800. I have 1, 2, 3, 0, so I know it's going to be 8,000. Some of you caught me on that. Thank you so much. 20 times 30 is 60. Or, see, I did it again. 600. I do that every time. You guys have to catch me on this. And then 20 times 4 is 80. If I add across to help me out, 80 plus 8,000 plus 600 plus 80 is 8,680. If I add that up, I think my answer, ooh, I didn't put this in, hold on. Do you guys know what I did there? The place value is not correct. So when I add 434, I would have added it really wonky. So let's go ahead and we just add that up. That's 4. 8 plus 3 is 11. So I have 1 10 and 1 100. 10 tens makes 100. 6 plus 4 plus 1 is 11, which is 1 100 and 10 100ths, which is 1,000. And then 8 added to 1 is 7. So I'm thinking my answer will be 7,114. So let's do our standard algorithm. Again, I'm going to multiply 1 by 434 first. A lot of you can say, well, I could multiply 1 by 4, 1 by 3, 1 by 4. Or we know that 434 multiplied by 1 is 434. All right, now let's multiply 2. So 2, 20, yep, we know it's 20 because the 2 is in the 10 spot. All right, so we have 20 multiplied by 4 is 80. 20 multiplied by 30 is the 600. And then 20 by 400 is 8,000. And then if I add all this up, we have 4. 80 plus 30 is 110. We're going to carry that 10 tens over. 6 plus 4 plus 1 is 11. So we have 1 100 plus our 10 100s. And 8 plus 1 is 7. I'm going to draw my arrows really fast to help me out. We know
that. Yes. 8 plus 1 really 7?
No, it's 8,000 plus 1,000 is 7,000. Thank you.
Well, but I'm still thinking 1,000 plus 8,000 is 9,000.
Oh my gosh. Why did I do that? Did you guys catch me on that? All right. So we can go ahead and know that, where did I get that in my head? Oh, well. But remember our mistakes. For some reason, something didn't click, but I'm now going to recognize it for next time, aren't I? Yeah. So we can see the top row of our area model matches our first row of our multiplication. Our second row of our area model matches our second row. All right, guys, so you have a few more questions that you, in the packet, if you downloaded that you can work on. And it's going into some word problems, and there's some more area models. So there's a lot there that you guys can have some fun and work with numbers, play with some math. So our next step that we're going to do is we had worked on the King's chessboard yesterday. And I had asked you guys, you notice I have a lot here, don't I? I had asked you guys to fill out the first part. When I had said, oh, try that on your own, I wrote a couple of them down, and then even in the thing, we had done a few. You noticed I told you guys I do all this math beforehand. I have everything I told you last time. I did it myself. And I even made boo-boos. It's okay. We just work on it. And we're all make mistakes. I want everyone to know that. So we're going to go ahead and we have all that up to 524,288 grains of rice on day 20. Did anybody keep going, try to figure out what would be on day 64? Was it exhaustive? You probably like, oh my gosh, it was a lot, right? Then we stopped on another page in the book, and they start to talk about the king's weigher said, to heck with this counting, I'm going to start weighing. And he went to 1 ounce, 2 ounces, 4 ounces, 8 ounces, 16 ounces, which was 1 pound. And then we kept going to where on day 20, he had 16 pounds of rice. So let's go ahead and let's see what happens. Because this is a lot that the king is now giving to the wise man. The King's Chessboard by David Birch, pictures by Davis Grubu, and it is published by Puffin Books. And yesterday we had talked about the 1 ounce, which happened here with the weigher. Only 4 days later, the wise man was sent a small bag of rice weighing 16 ounces, or 1 pound. He placed 1 grain on the 16th square of his chessboard and gave the rest to a beggar. But as the granaries, the weigher had become worried. Tomorrow, he said to himself, it will be 2 1-pound bags, and the next day it'll be 4. He calculated the amount 8, 16, 32. When he got to 2,048 bags, he stopped in alarm. I must tell the grand superintendent of the king's granaries at once. But when he was actually standing before the grand superintendent, the weigher became so nervous that he didn't say what he meant to say. Your Excellency, he smuttered. Excuse me. The rice sent to the wise man is, excuse me, how many small bags of rice are there in the king's granaries? What kind of question is that? Demanded the grand superintendent. Where have you been drinking? No, Your Excellency, the weigher said. Then he hurried back to his scales and promised himself not to be bothered anybody again about the wise man's rice. It was only 9 days later that the grand superintendent saw 4 granary workers carrying stacks of rice from the granary. Following them was a group of ragged children. Here, stop, shouted the grand superintendent. Where are you going with the king's rice? When the children laughed at this, the grand superintendent demanded, and why are these urchins so merry? Your Excellency, said one of the granary workers, we are carrying this rice to the wise man, who then gives it away to the poor and hungry. Impossible, said the grand superintendent. That fool of a weigher has made some mistake. But there had been no mistake. It was explained how 1 grain became 2, and then 4 grains became ounces. Ounces became pounds, a bag became 2 bags, and today it was 4 sacks, each weighing 128 pounds. The grand superintendent said to himself, tomorrow there will be 8 sacks, over half a ton. I must tell the king. But the king was away hunting in the mountains that day and the next. So on the day after that, the grand superintendent had to send the wise man over a ton of rice. The next day, it was 2 tons, and still the king had not returned to the palace. There was nothing to be done. The next day, 4 tons, then 8 tons. Oh my goodness gracious, what do you think is going to happen? On the day after that, when the king returned, he heard a great cheering outside his palace. From his window, he saw 16 wagons, each carrying 16 sacks of rice, over a ton on each wagon. The wagons were followed by a crowd of happy people. Where are those wagons going? The king demanded. Sire, said the grand superintendent of the king's granaries, that is the rice being sent today to the wise man. Impossible, said the king. You have made some mistake. I fear not, sire, said the grand superintendent, and began to explain how 1 grain became 2, and then 1 ounce became 2 ounces, then a pound became... Enough, said the king. Summon the royal mathematicians. The mathematicians appeared and were ordered to determine how many tons of rice the king had in fact promised to the wise man. After an hour of calculating and recalculating, the chief mathematician rather nervously held up a slate with their answer for the total of all the rice that was to be sent for all of the 64 days. As the king read the number, he grew angrier and angrier. 277,877,906,944 tons. Tons, roared the king. Tons! Deception and treason. He then ordered everyone from his presence except the queen. He sat and glared at the chessboard with its 31 grains of rice. 31 days since he insisted the wise men should be rewarded. After a time, the queen said to him, "You must ask the wise men to release you from your promise. It is the only thing to be done." But the king seemed not to hear. Finally, the queen left him alone with his anger and silence. There he sat all day, and there he stayed all that night, doing dozing fitfully until he was awakened by the first light of morning. Below, he saw a line of 32 wagons leaving the granaries and huge, happy crowds following them. The king sighed. He placed a grain of rice on the 32nd square of his chessboard and then gave orders to summon the wise man to the palace. "This must stop," said the king to the wise man. "There is not enough rice in all of India to reward you." "No, indeed, sire," said the wise man. "There is not enough rice in all the world." "Then," said the king, "since I have promised you the impossible, I command you as my loyal subject to tell me how you would be satisfied." "But I am satisfied, sire," said the wise man. "It is as I tried to tell you, sire. I have always been satisfied. It was you who insisted on rewarding me. It is you who must be satisfied." As the wise man spoke those words, all the splendid people in the great hall became very, very still. "Are you satisfied, sire?" asked the wise man. And although he spoke quietly, everyone heard him as if he had shouted. No one whispered, no one moved. "Yes," said the king at last. "Yes, I am satisfied." Then he smiled at the wise man, not a happy smile perhaps, but a genuine smile. "And I understand," the king said, "that in all this you have done me yet another service." "Then, sire, I am truly rewarded," said the wise man. With that, he bowed very low and left the great hall. The wise man returned to his simple home and quiet life, and although he was to serve the king many times afterward, the question of a reward never again arose. The king ruled wisely and justly for many, many years, and to the end of his days he kept the chessboard with its 31 grains of rice to remind him of the wise man's lesson. How easy it is for pride to make a fool of anyone, even a king. So, I had asked you if you guys went up to all the way to that large number of 64, and I don't know, maybe you did, maybe you didn't. All right, for this next activity that we're going to be doing, we are going to be reading another story, but it's Grandfather Tang's story. And in this one, he's going to be working with tangrams. Yesterday, we worked with squares and how many squares were in there. This time, I wanted to bring a triangle and ask you, how many triangles do you see in this? So, letting you guys know, it took me a while to figure out the answer of this one, but I want you guys to try to figure that out. But let's go ahead and let's move into the story. Grandfather Tang's Story, A Tale Told with Tangrams by Anne Tombert, illustrated by Robert Andrew Parker. Published by Dragonfly Books. Grandfather Tang and little Sue were sitting under a peach tree in their backyard. They were amusing each other by making different shapes with their tangram puzzles. "Let's do a story about the fox fairies," said little Sue. So Grandfather Tang arranged his 7 tangram pieces into the shape of a fox. Then Grandfather Tang made another fox with little Sue's 7 tangram pieces. Little Sue clapped her hands as her grandfather began. Although Chow and Wu Ling were best friends, they were always trying to outdo each other. One day, this rivalry almost brought their friendship to a tragic end. They were sitting under their favorite willow tree beside a river, talking about their magic powers. "I can change myself into a rabbit as quick as a wink," boasted Wu Ling. "I'll bet you can't do that." I can too, said Chow. Cannot, said Wu Ling. Anyway, actions speak louder than words, and he changed himself into a rabbit. Do you guys see the rabbit down here with the 10-gram puzzle pieces? Not bad, said Chow, smoothing his whiskers, but watch me do better than that. And before Wu Ling could blink, Chow changed from a fox into a dog. Now, when Chow changed himself into a dog, he not only looked like a dog, but he felt like a dog and acted like a dog. He bared his teeth and lashed his tail. Wu Ling shivered and twitched his nose. I love rabbits, Chow growled, and I'm going to get you and gobble you up. The dog edged closer and closer. Wu Ling's eyes grew bigger and bigger. He was too frightened to move at once, but then he thought, I'll be safe if I climb up a willow tree. His little puff of a tail grew long and bushy, and his tall ears shrank as Wu Ling transformed himself into a squirrel. Wu Ling sprang into the willow tree and scrambled to the top. Chow will probably turn himself into a cat so he can climb up the tree after me, Wu Ling said to himself, but he'll never catch me. I'll jump from tree to tree, and he won't be able to follow me. Of course, Chow thought about changing himself into a cat. But that's just what Wu Ling expects me to do, he said to himself. What can I do to surprise him? He thought and thought. I know, I'll swoop down upon him from above. And he turned himself into a hawk. I'm going to stop there because I have an activity for you guys. Online, there is a 10-gram puzzle that you can print out, cut up, and do with me. And our activity that we're going to be doing that I'd like you guys to work on is in these 10-gram puzzles, I'm asking you to take these puzzle pieces and figure out how many triangles can you make with a certain number of pieces. So if I said one piece only, how many triangles can you make? Well, if it's one piece, I know I have a large triangle, a medium-sized triangle, and then I have a small-sized triangle. I can't make anything else. I can't take my square, split it up. I can't do any of that. So I'm kind of stuck there. That's one piece. If I had two pieces, how could I make a triangle? Well, I know that if I took two of my little triangles or my big triangles, I probably could use that to make another triangle, right? Can I make any other triangles with two pieces using different pieces? Can I make, using 3 pieces, can I make different triangles? 4 pieces, all the way up to 7 pieces. So for example, for 3 pieces, I know I could use a square and my 2 little triangles. Hold on, I think. Yeah, there we go. See, with 3 pieces, I can make another triangle. So the other thing on the online is a sheet of paper where you can help organize this, where you can actually draw it out. So try it out. See if you can use all 7 pieces and make one triangle from that. All right. So now we're going to move into our game today.
And can you make those pictures that were in the book too?
Oh, they could.
I think that would be fun. That sounds like a lot of fun. All right, let's do that. And you can see Miss Gaudette had a lot of different things for you. Those are all those resources that are going to be available for you online there. So if you just check that out on our aps.edu, you can go up to our K&ME work and pull off those resources. All right, so the game that we're going to be playing today is called Decimal War.
Ooh, you know how I like war.
So let me explain a couple of different things. You can use a spinner that has 0 through 9, and we have those resources available, and we have our spinner up there. You could also use your Uno cards that would have your digits on there, 0 through 9. You really couldn't use a playing card, but you could use the digit cards that we added onto our resources as well to do that. And you'll also need, there it is, you'll also need 1 die. okay? Because as you notice, what's different about what you normally know about war? You're probably just playing the cards and, moving the cards around and giving them to the other person. This time we have a game board. Ooh.
Dun, dun, dun.
So me and Miss Gaudette we're going to have to pick a spot where we're going to be located, and we're going to do different colors. And if you can see down here at the bottom, we have our decimal configurations. What do you notice about that? Well, we have, it looks like a whole number, right? And then we're going to have the decimal portion that is going to go into the thousandths. Hope I didn't get you wet out there. Thousandths. So part of this is that we need to make sure we're saying the number correctly, okay? And can we say the and? This is not one of those games that you're going to be able to catch us not saying the right things. We can say and because we have a decimal. Woo. All right. I also have a game map that is there for you that's downloadable in the resources, and it starts off with just your ones, tenths, and hundredths. But then it also goes into where you could do your tens and ones and maybe a tenth. So there's lots of different ways that you can play this. So it's kind of interesting. We're going to play it up to the thousandths, but we got to build our number. And that's part of the strategy of what we're going to be doing. So Miss Gaudette, if you will go ahead and get us started, I will tell you how we play decimal war.
Do you want me to spin it?
So spin it for me. And that's why we have these blank spaces down here for the decimal. I'm trying to build the biggest decimal.
Okay, so then my question next is, whatever I spin, do I have to automatically put it on?
We're going to put it in a place. So what did she spin for me? She spin me a 1. Would I want to put that in my ones?
Okay, so we can move it around.
You can move it around,
Okay.
but once you place it, it is there. Okay, and we're competing against each other because whoever wins the round gets to roll the dice to move forward on the board. Okay, so she got me a 1. I'm going to put that 1, since this is a very low number and I'm wanting to build the biggest number I can, I'm going to put it over here in my thousandths place. All right, let me change your color so you can do that.
So
You roll.
do you say your number? Because right now you have 1.
I have 1. No, I will wait till reserve it till I get all the numbers in there.
Oh, when you
We
say
go
it,
one at a time.
You don't say it at each
We
time?
could. I mean, 1. That's just a lot of things. 1 thousandths.
I actually like saying it each time, no matter what you have, because then
That
it
makes
helps
sense.
you practice saying it,
That's
which
true.
is a big thing for
That is a
all of
big
us.
word. 1 thousandths. I have 1 thousandths right now. Wow, that is a very, very small, tiny number. All right, you have an 8.
All right.
She
So
did that
my
on
thought my thought, I could either put it here in the 1 spot, or I could put it in the 10th spot, but then I'm taking a chance, hoping that I'm going to get either 8 again or a 9. All right.
Decisions.
I know. I hate to take a chance because I'm one of those ones, so I'm going to put in 8.
So right now,
My number is 8.
8 ones, which is has the value of 8. Okay, you ready to spend me a good one?
Don't I get to roll?
No, you have to wait till the whole number gets through.
Oh.
That's why I was saying it's going to take a long time to go through each of the numbers. But you wanted to say the number every time we did
I
it.
didn't know that. I thought I got to keep
Yes. I thought, well, okay, why is this going to take forever? Okay, she got me. This is rigged. She gave me another 1. Okay. This time I'm going to put it in the hundredths place. I'm going to go ahead and, let me change the color. Actually, maybe I should leave it red, huh? Yeah. I'm going to put it there. So I have 11 hundredths now in my number.
Well, now that I know that I didn't get to keep rolling along.
Oh, she gets another 8. I think she's got this somehow working for her in the favor there.
So I can either put it in my tenths, hundredths, or thousandths. Because I'm thinking I'm probably going to get a 0 or 1 very soon, I'm going to put it in my tenths.
All right. Ready? And what is your number, since you made me do this?
8 and 8/10.
Okay, thank you. I was like, so I don't have to say it every time? All right, 4, okay. I'm still holding out that I'm gonna get a better number. And I don't really wanna put a 4 in my ones because I already know it's gonna be a smaller number. So I'm gonna do the thing and put it into my tenths. So I have 411 thousandths right now.
All right, I'm gonna
Notice
spin.
I'm using the place value of the very last digit that I'm calling on this one. Yeah, so I have 411 thousandths right now is my number.
I got a 0, so I'm gonna put that last. So right now I still have 8 and 8/10, or I can say it as 8 and 800 thousandths.
Assuming that there's a 0 holding that place in that hundredths, yeah. Right now we don't quite have the full number, right? Okay, I'm really hoping 9. All right, I have a 3, okay, so I have 3 and 411 thousandths. That was my number. I'm not gonna probably move. I already know she has an 8, right? I'll move that over there so she can do it.
All right, I have a 9, so my number is 8 and
9 couldn't have come to me.
890 thousandths, or 889 hundredths. Because a 0 means I don't have any. I can just look at it as hundredths.
How come you have, I guess I didn't change the color for you. You have blue on there on the end. So that must be my numbers now. I'm going to take that 9.
4. So 1, 2, 3, 4. So I'm,
No, you could put that.
oh, I bet I could.
Yeah.
I bet I could.
All right. So can we just erase our numbers and we start
Actually,
over?
clear the whole board.
Clear the whole board.
No.
Okay. Will you remember where
Clear
you're
the
at?
whole board. There you go.
There you go.
And
Will you
then-
remember where you are? You were right here, right?
Yes.
All right. Let me get that for you. Oop. Goodness gracious, Mrs. Sears. We will go. We say that. Oh, you must have had something else behind mine. All right. Yep.
Oh my God.
This is not my thing today here.
Here. No, they don't
We'll
have it.
get it. We'll get it. Okay. So just go ahead and spin for me while I'm figuring this out. I will get it eventually. Maybe that's why it's not wanting to do
Post-it
it.
note. Post-it note.
Am I on a Post-it note? Is that what I'm on?
No.
Lovely technical difficulty.
Close that out.
Close that out.
Start it up again and see if it helps.
Let's see if that works. There we go. Technical difficulties. You guys will have better luck on yours when you go. All right.
9.
Back to me. All right. Here we go. My chance. I'm going to stick with that 9. I have 9 ones. 9. That's what my value is. See, I think this is how it must work. We're going to have to go back and forth.
I have 1,000.
Thousandths. Remember, you call out the place value of whatever number you're on the end of. Yeah. Okay, she's got a 1. Here we go. I'm going to leave that 1 there. I guess we could leave the color the same. We know that that's her side, this is my side, right? This way we don't
I
get
have
confused.
4.
Okay, where do you want it?
I'm going to put it in the
Come on, put it in the ones.
tenths
Put it in the ones.
place. So I have right now 401 thousandths.
All right, roll again. We're going quicker now. It's not as much time.
Well, because I had to figure
Hopefully
it out.
we'll be able to see if I can get ahead of you. She got me a 1 again. I'm going to do the 1. So I have 9 and 11 thousandths. Put it in the ones.
Well, if we were going for the lowest number, I could have. I have 401 thousandths.
That is a variation. You could do it. All right.
I just want to see what your last
All
number
right.
is.
Let me see what my number is. Come on, 9. Come on, 9.
Well, if you have 9, no matter what.
I have a 6. That's not bad. That's actually better than my ones. I have 9 and 611 thousandths.
All right, she's
All right.
going to beat me.
We're going to see where I am, and then probably you're going to be wrapping this up here in just a minute.
I have 3 and 401,000.
All right, let me see if I can roll further so I can make something out of it.
She got a 2.
I rolled a 2. Okay, so that means I only ended up here. Miss Gaudette ended up winning that for us. So we have had a really cool day today, done lots of different things with you, and we hope that you kind of get online and you check out those resources, but we want to thank you for joining us at home with APS. Have a great day. Bye-bye, mathematicians.
Bye, everyone. Have a great afternoon.